Welcome to my video on the cosine function. This is for right triangles. So before we define the cosine function, we need to draw a right triangle here. And a right triangle has one angle, 90 degrees, so that's going to be a right angle. Now we start labeling these, and the angle opposite of the 90-degree angle, we'll call that theta. Now the opposite of the right angle is called the hypotenuse. And we know that's the longest side of the triangle. Call that C. Now, the adjacent angle, or the adjacent side, is right here. And that's adjacent to the angle theta, but not the hypotenuse. So let's just call this as the adjacent side, and then we're going to label that A, of length A. And then this last side right here, opposite the 90-degree angle, we're going to call this the opposite side. And that is going to be of length B. Okay, so now we've got our right triangle. We know where all the pieces are. So let's define the cosine function. In the last video, we defined the sine function. I've got a link to it in the back. But now let's define the cosine function. It's very closely related. So the cosine of the angle theta is equal to A over C, which is just the adjacent over the hypotenuse. So that's going to be this length of this angle side divided by the length of this side. So that's A over C. So it's a ratio. But now since we've got a right triangle, that puts some limitations on theta. So in this case, theta can only be 0, or if I go straight up here, it could be 90. So 0 less than theta less than 90. So that tells us what theta can range to. Or if you want to do radians, that would be pi over 2 radians. So there is our basic definition of the cosine function. So now let's look at some cases here. Let's look at for small theta. So that's going to be the case where we've got a long, skinny triangle here. There's our right angle. There's going to be our side B, our opposite, our hypotenuse, angle theta. And then there's our adjacent side. So in this case, our definition of the cosine function is A over C. So A divided by C is approximately 1 because they're both long. It's not exactly. So the cosine of theta going to 0 degrees is approximately 1. In that case, that's where it goes to. Now let's look at the case to where here's our right triangle. There's our angle theta. Our 90-degree angle. This is going to be our angle we're just going to essentially stand it on its edge. So now in this case, here's our angle theta. Excuse me. This is our angle theta. And it's going to be very large. It's approaching 90 degrees. So it's going to be going to 90 degrees. Now there is the opposite, which is going to be B. The adjacent, which is going to be A. And then there's the hypotenuse C. So there's going to be our angles. Now this is when theta approaches 90 degrees. That's our case here. Now A over C in this case, A is going to be very small, so it approaches 0. And C is going to be large. We're going to call that C. So in that case, it's going to be approximately 0, or it's going to approach 0. So when A is very small, in this case, when theta is very large, that's going to go to basically 0. We're looking at kind of the limiting case. We're trying to get a feel for what range the cosine varies over. So the cosine of 0 over C is going to go to 0. And that's going to be for approximately a 90 degree, when we're approaching 90 degrees. So that gives us an idea. So 0 degrees approximately is going to go to 1. At a large angle, it's going to go to 0. So that's the range of our cosine function. But this is limited for a right triangle. We'll later look in other videos where we're going to talk about it over the entire range of angles. So we're just limiting to this one case here. Now let's do an example. So here's a nice little right triangle. Extend that out a little bit here. Now, let's verify that that is a 90-degree angle. So we get our protractor. Okay, we are dealing with 90 degrees. The protractor tells us it is 90 degrees. So that is a right angle. Now let's start measuring the dimensions of this. First of all, let's just measure that's going to be our angle theta. Let's see what that is. Okay, that's going to be approximately a little over 30 degrees. I'm going to call it about 32 degrees. Measure our dimensions here. We'll use the millimeter scale. That's going to be 80 millimeters. And this is going to be our length. Let's see, this is the opposite, so it's going to be B. There's a hypotenuse, C, so this is length A. This is our long side, that's hypotenuse. Let's measure that next. And that looks like that's going to be about, what is that? What did I get there? About 95 millimeters. So there's our length there. Now let's measure the length of side B, and it looks around 50 millimeters. So what we want to do, we want to verify that the cosine of theta is equal to A over C. That's what we're going to do with this real triangle right here. We're going to verify this relationship. So first of all, let's do the cosine of 32 degrees. I'm going to use my HP calculator to do that. Let me clear it. Now I'm going to type in the cosine function, 32, close the parent, hit enter, and that is going to be equal to 0.848. And there's a bunch of other digits, but I'm not going to worry about those. Okay, now set that aside, and A over C now. A over C, so A in this case, what did we get here? We got A is 80 millimeters, 80 millimeters divided by 95 millimeters. The millimeter units go away, so that's 80 divided by 95. Let's do a clear. 80 divided by 95, enter, and that is equal to 0.842, on and on. Now, it looks like within reasonable measurement errors. So what we just validated was that the cosine, which is that angle theta, is the ratio of the adjacent over the hypotenuse. There's our hypotenuse. And then there's going to be our adjacent angle A. So there we have it. We developed the definition of the cosine function for a right triangle. And what we did, we validated with an example that the cosine of 32 degrees is equal to 0.848. The ratio of the A over C, the adjacent over the hypotenuse, which is the definition of the cosine, is 0.842. Well, I hope you got something out of this video and learned a little bit about the cosine function and how to calculate it and what it is. And thank you for watching.